Hey everyone, today we are going to solve a statistic question from a past paper 2023 based on frequency tables, probability, and expected value. Let's get started. Here's the scenario. At an amusement park, 40 visitors were asked how many times they rode the dragon. Their responses are summarized in this given frequency table. We'll assume this data represents all visitors to the park the next day. Let's find the probability that a visitors ride the dragon, the expected number of rides, and how many times the ride must run for 1000 visitors. For the part A, a visitors ride the dragon at least once if they rode it one or more times. Out of 40 people, 6 didn't ride at all. So 40 minus 6, there are 34 people rode it at least once. So probability of rides will be 34 upon 40, which is approximately 0.85. So the probability that a randomly selected visitor rides the dragon is 0.5. That's the answer for A1, 0.85. Now for the B part, the expected number of rides. That's the average value using the formula. The expected value will be summation f x divided by summation f, where f is the frequency and the x is the data. So the formula will be expected value of x will be 0 times 6 plus 1 times 16 plus 2 times 13 plus 3 times 2 plus 4 times 3 divided by sum of the frequency, which is we already know 40. So when you multiply, this will give you 0 plus 16 plus 26. 3 times 2 is 6 plus 4 times 3 is 12 divided by 40. So the answer will be 60 divided by 40. When you simplify, it will give you 1.5. So the expected number of times a visitor will ride the dragon is 1.5 times per person. For the B part, it is known that 1,000 visitors will attend the amusement park on Tuesday. The dragon can carry a maximum 10 people each time it runs. So on Tuesday, 1,000 visitors are expected. Each visitor rides a dragon on an average of 1.5 times. That we know from the second part of A. It says expected value is nothing but 1.5. From this, we can say each visitor rides a dragon an average of 1.5 times. So total rides needed is 1000 times 1.5, which is 1500. Each ride can carry 10 people. From this, each ride can carry 10 people. So the number of runs needed is 1500 divided by 10. So answer is 150. So we can say the dragon must run at least 150 times to meet the demand. That's the final answer. That's it. I'll see you in the next video where I'll solve question number 4. Subscribe for more IBDP related videos. Thank you.